Hello, I'm Mausmi Ambastha, and today we are going to discuss about the next topic in the series of performance metrics. The key performance matrices for quality control in a garment factory. We all know quality is non-negotiable. You have to build quality in the garment, and we all struggle to maintain the quality standards that are necessary to make good product. But do we know all the measures? In this video, we'll be discussing about various metrics that will help you in measuring quality in your factory, maintaining and improving it. The quality measures that we'll be discussing are right first time or first time right, percentage defective level, defects per 100 unit or DHU, acceptable quality level or AQL, value added and non-value added time, lost time, style changeover time, efficiency and productivity. The first metric we are going to discuss is right first time or RFT percentage. You would agree that our time and energy in a factory should ideally be spent in producing good quality garments and should not be spent in doing repair or rework. However, if we make mistakes, repair and rework is going to happen, and that repair and rework basically eats into the product margin. Therefore, we should produce the right product the first time when it is being produced. The measure of RFT is number of good products produced without any repair and rework divided by total number of garment produced by the line, which should include all the repairs, reworked, scrapped or rejected garments as well. This can be measured at the end of the line or at the end of the operation or at every inspection point within a factory. To understand this in a simple example, let's say a factory or a line produced 450 garments and they are being inspected at the end of the line, out of which 50 garments were sent back for repairs or rework. Then the RFT level is 88.89% for that particular inspection point or that line. The next metric we discuss is percentage defective level or defect percentage. It's the basic measure of quality and is the most popular way which most factories, end-line inspections or finishing departments use to measure their quality levels. It's simply the number of defective garments produced divided by total garments that have been inspected at the end of the line. This can be measured by per operation, per section, per line, per order or per inspection point as and when it is required. It is normally expected to measure it hourly to control the quality production in a factory. To understand it in a very simple example, in the previous example we discussed, there were 50 garments that were defective out of the 450 garments inspected by the inline inspection team. So the quality level or percentage defective level is 11.1%. The next metric is defects per 100 unit or DHU. It is one of the popular methods of measuring quality, and as the name suggests, it's basically number of defects found per lot per sample represented as a percentage. Number of defects or each defect that is found in a garment basically adds to the workload of repair. So when you found 3 garments, it's also required to count how many exact defects were found within the garment. So let's say in the previous example, we inspected 450 garments, out of which 50 were found defective. Now let's say 20 garments had 3 defects each, another 20 garments had 2 defects each, and 10 garments had 1 defect each. So total number of defects found in all these garments were 110, and 450 garments were inspected. So DHU or defects per 100 unit in this case is 24.4%. DHU also helps us in finding out exact quality bottlenecks or particular defects which are causing quality issues in a production process. The next metric is AQL or acceptable quality level. AQL is an inspection standard which tells us how many pieces are acceptable to be defective in a certain lot size or sample size for the shipment to pass. AQL table is a table which states that for a certain lot size, how many samples are required to be inspected, and what are the limits between acceptability and refusal considering a standard quality level. AQL basically requires you to classify defects into critical, major and minor, and the level are determined based on the accepted standards between buyer and seller. So let's say buyer and seller agree on an acceptable quality level or AQL level of 1.5, then the table is used accordingly. Say a buyer follows general inspection level 2 and AQL level 1.5, then in this particular example that we discussed in the last case, let's say 450 pieces were the lot size. So AQL states that 50 pieces need to be inspected. If 3 or more defects are found in these 50 pieces which are major, then the shipment is considered to be rejected. The next metric is NVA or non-value added time. Basically it is a waste. Any time that is spent in doing activities which are not adding any value to the product is considered as non-value added or wasteful. It is ideally not possible to eliminate all non-value added times. However, it is essential to evaluate all the processes and determine which can be eliminated. Let's understand this with an example. Let's say for a garment, if you are creating notches to match both sides in the collar, it is not adding any value to the product itself. However, it is essential to do that activity such that the entire quality of the product is not compromised. However, on the other hand, if there is a waiting time before process, then that is essentially non-value added and it can definitely be avoided. And there should be an activity or analysis to identify waste, eliminate them and in future improve them. Value stream mapping is a process which helps you in identifying all the elements in a process flow which are value added and the processes which are non-value added, so that you can focus on these processes and try to eliminate and reduce them. The next metric we are going to discuss is lost time. Lost time is the time that an operator loses with no fault of theirs. It might not seem much, it's few minutes here and there, but if you actually measure it, it would be a substantial amount of time that is being lost out of actual productive time. Lost time can be caused due to incorrect line balance, waiting for the work, there could be incorrect directions in terms of work, or the operator is performing somebody else's repairs. All this time has been lost out of the productive time for the operator. And in a factory, one should always try to eliminate or reduce it. It is easy to identify what a lost time is, but it's much more difficult to actually measure it, eliminate it eventually by improving the processes. Reducing lost time can actually result in a reasonable increase in your production time. Style changeover time is the time it takes to complete the entire manufacturing setup from style 1 to style 2 as per the accepted performance and quality standards. It can be measured at the end line inspection from the time it took for the last good piece for the first style to come out and the time it takes for the next or first good piece for style 2 to reach the end line inspection table. The next metric we are going to talk about is efficiency. Efficiency is the comparison of the number of pieces that can be actually produced or performed as compared to the number of pieces that can be produced or performed within the same amount of time, money or labor. So in formula terms, efficiency is defined as standard minutes earned divided by actual minutes attended on the production floor, or in a simpler way, number of pieces produced divided by the target number of pieces that should have been produced. Standard minutes earned can be defined as achieved production or actual pieces produced multiplied by standard minute for production of each garment. To achieve correct efficiency, we should keep in mind that standard time should always be established by internationally accepted performance standard or standard time calculating procedures. Let's take a simple example to understand now the calculation of how efficiency works. So let's say an operator works 8 hours a day, so 480 minutes during the day, and during this time there were 30 minutes of machine breakdown, 10 minutes of production meeting and 30 minutes of waiting for work. So he spent 70 minutes on non-productive time or lost time. So the time that was available to the operator for actually performing the work was 410 minutes. During this time, he produced 22 bundles of 10 pieces each. The standard time for every piece was 1.4 minutes. So the standard minutes he earned is 22 into 10 into 1.4. So he actually worked, or standard times that he earned is 308 minutes. So to calculate the efficiency, standard time earned divided by total available minutes is 308 divided by 410, which is 75.3%. The calculation for achieved production divided by target would also give you the same efficiency percentage, and it's a reasonable measure of how good your factory floor is running. The last and one of the most important metric of quality is productivity. Productivity is generally measured as output divided by total number of input resources. It can be measured as partial productivity in terms of machine productivity or labor productivity. Total productivity obviously assumes multiple input and output parameters. The most popular productivity term that is used in our industry is output per machine per operator. This can be measured but should not be compared in between multiple factories unless both of them are producing similar garments and similar machinery and equipment. Productivity and efficiency are two terms that are generally confused, but now we understand that these are two very different parameters and different elements to be monitored independently. Having efficiency or high efficiency does not guarantee good productivity, and productivity does not guarantee a better efficiency. None is complete without the other, and both should be monitored independent of each other. In this video, we learned about various quality parameters and key performance indicators that can help you manage your quality in the factory. If you enjoy such videos, please remember to like, subscribe. You can also go to our channel Stitch Diary on YouTube, or you can check out our blog stitchdiary.com.